Now, I've mentioned incidents. Incidents are a collection of alerts that are related by entities. The goal is to try and address basically alert fatigue because it is quite common to have a large number of individual alerts that are all related. In particular, every one of these lines is one or more alert. One alert, two alerts. Just on this screen, I'd have to do math real quick, but it's about 10 individual alerts. Now, these are related using a technique called GraphML, which is a very modern both graph analysis and graph machine learning. These are, very modern techniques with a great deal of power. The key to remember is that this whole incident, all of these alerts are an incident. The idea of an incident is to represent an attack. The other idea of an incident is that we may have a number of individual alerts that have a lower score, right? We should still be looking at, I don't know, what's the correct analogy? We should still be looking at the, big house fire. I'm in California, so perhaps this analogy is, specific, but we should still be looking at that big house fire, that high score alert. But if we see a lot of little brush fires, that's also reason of concern because that can grow. And then finally, as I showed you in the teaser, we are able to group alerts into an incident. Let's talk a little bit about graph machine learning. Graph theory, the idea is we have nodes and we have relationships. That's the key idea. Just to bring it back, the nodes are these entities and the relationships are the alerts. Graph machine learning finds these interesting relationships. And the analogy that was used that I really got, made a lot of sense to me. And some of this is going to be, some of these, maybe this is a very America specific. So please don't, I'm in America. If someone buys a ski mask, this is not necessarily a big deal. Maybe they want to go skiing. Maybe they live in Wisconsin where it is very cold. And if someone buys a gun, this is very legal in the United States, whatever our, opinions may be. And if someone happens to live in a town and happens to walk past a bank quite frequently, that happens. That would be a relatively low scoring alert. But if the GraphML notices that someone has bought a ski mask and bought a gun and is walking back and forth in front of a bank, maybe that warrants some additional investigation. And that is the basic idea behind incidents. There's going to be a lot of connections between things, and some group of those are going to seem weird, which is what anomaly detection is all about, is finding things that are weird so that a human can go investigate the details above and beyond. That, all right, maybe not every needle in this needle stack is actually out of place, but for some of them, something is going on. Now, the progression of an incident when they are generated by the system. So some incidents are generated by the human analysts who group like, oh, this and that are related. I know because of my whole network topography and know what's going on. But machine learning sees that some alerts are related and so adds that to an incident. But that initial incident score is going to be relatively low. The alerts are low, the incidents are low. The relationship are the alerts, the various entities, host name, IP addresses, etc. These are going to be how they're connected. And then as time goes on, if the GraphML notices, oh, wait a minute, this other alert is related, oh, wait a minute, this other alert is related, then the score is going to increase. And then when the SOC takes some kind of action, they notice, granted, we're not instantaneous, maybe it took a little bit, but the SOC takes an action to block the attack before bad stuff. And then we have, whatever additional cleanup needs to happen. It it's unfortunate. It does happen. Sometimes a system, gets damaged. The big stuff didn't happen, but we do still have some costs, and that's kind of the nature of the situation. And then once response and remediation cleanup have happened, then we can close the incident, close the case we made in our case tracking system, and we're ready to go. All right. We have in an incident, let's go to the user face. We have incidents. Here's an unassigned incident. Oh, that was made by someone. Yeah, it was made by a person. I can tell, just so you know, creator, it was a username. Also, the name of created by system start out with these semi-generic names. All right. But we have some interesting things. We have a status. We'll talk about that for workflow. We have the ticket ID, incident ID up here. We have a priority, which you will, as an organization, decide what constitutes critical. Is it because, you're looking at these specific hosts and like this one host is important, or there's going to be policy going back to the NIST standards that we're going to have to put in place. Who do we assign it to? If we are going to have to put in place. Who do we assign it to? If we are doing that as a process in our organization, creator system that's set by the creation, we can create tags. Tags are used up here. And again, we have to be careful about our tags. Test 1, test 2. Why are these tags here? Like this list, if you can imagine, we don't want this list getting to 1,000 long. So we're going to have to do some internal organization to make sure we don't get too crazy with it. Summary provides a machine description of what was noticed. Description is where we can type stuff. And again, we'll want some policies around how that happens. And then metrics describe some, when was it created? When did it get updated? Etc. and so forth. All right, so that is some information. Let's talk a little bit, etc. and so forth. All right, so that is some information. Let's talk a little bit about workflow. There's a good question about incidents. What will happen if I resolve the incident case in the middle of incident progression? So that is an excellent question, although I do have some ambiguity of what you mean by the incident case. So I'm assuming that you meant there was an alert, that you then created a coordinating case tracking system, and that not you, but the organization decided that, oh, this ticket is closed, but you did not set the status of the incident to either resolved or canceled. Is that the question? Like the coordination between the two systems that might be? I'll let you answer that, and I will move on to my next section, but I may wait until we talk a little bit. So when I use the term case management, I'm talking about the system that allows us to coordinate as SOC analysts with IT departments or other organizations like our MSSP partners, because they may not have access to the data processor. Now, if what you mean is, are you asking what happens if someone goes in and sets the status of this incident, but then another alert comes in that would have otherwise been associated with the incident? Is that the question? And I'm going to move on. I think some of this will be a little clearer also in a moment, but please ask the question. And I will definitely answer it to the best of my ability, given it depends. Okay, so the question is, what happens if there is some incident and a very zealous person goes in and addresses all of the alerts and everything else associated with that incident. And then a new alert comes in that, had the incident not been closed or canceled, would have been associated with the incident. Well, the simple answer, the very short answer, is that this new alert will generate a new incident. And there are some complexities and specificities that we can look at. But the very simple answer is, if there is no incident that an alert can associate with, either because GraphML says it doesn't associate or because the original incident is closed, then that will generate a new incident with some caveats I will talk about in a few moments. Now, at the same time, if you have closed an incident, that does suggest that you have decided it either is not relevant or you have already begun some kind of action or other remediation, which then which then raises the question, why did a new thing come in? And, that now we are spiraling into a lot of additional interesting technical things, and there's not a simple answer to it, right? We would have to look at very specific situations. So the very basic question I hope I've answered, and I hope I have illuminated some of the additional considerations we would have to make. There is another question in the line, but if there's more detail I can provide, please let me know. But you raise a very interesting point, which is one that in some senses, as an organization, we will need to deal with in a policy system. But it's also, good to know behaviors. So I'm going to mark that as done. I'm going to move on to the next question to give you a chance to elaborate. Okay, so is it possible that stellar stars detected non-critical alert can actually be critical? All right, so this question, I'm assuming, if you can please confirm, is for an individual. Trying to find a good example. All right, let's just bop that down, get everything open. All right, this one critical, 1.5. All right, so we have notice, we have critical. Let me just add to this column. We'll reset columns. That was a good idea and didn't quite work. So let's, there's the alert score. Let's find. All right. The definition of critical as it stands quite work. So let's, there's the alert score. Let's find. All right. The definition of critical as it stands today, April 4th, 2022, is that a specific alert has a fidelity of 75 or greater. As I discussed in the 101 class, fidelity, especially for the unsupervised machine learning, is a measure of our likelihood that this specific alert of this specific type, outbytes anomaly, is anomalous, right? That is what we are attempting to communicate. with the fidelity is anomalous, right? That is the what we are attempting to communicate with the fidelity is that this top one is really weird. Let me go in and add past week. Let's go to all alerts. 6622. They're all the same. So on my test system, unfortunately, I can't really demonstrate it. All right, maybe I can. So application data, uncommon application anomaly. Maybe I can demonstrate it. So let's pull up fidelity. And severity. All right. So this and severity. All right. So this particular alert type, uncommon application anomaly on kill chain initial attempts, has a base severity of 20. All right. And based on machine learning for this specific source host, the specific whatever application, Gmail, actually, I may need to go. That actually is really weird. Oh, I know what that happened. I know what happened here. On that day, back, yeah, these were days I was testing on the second and third. I was testing email stuff, and I hadn't tested. That's actually my data processor address, and the system, the overall network noticed why application Gmail. Actually, I may need to go. That actually is really weird. Oh, I know what that happened. I know what happened here. On that day, back, yeah, these were days I was testing on the second and third. I was testing email stuff, and I hadn't tested. That's actually my data processor address, and the system, the overall network noticed why is this host sending to Gmail? Well, it was because my system was very quiet. So that's why it was 100 fidelity, and that's what critical means. Is the fidelity is greater than 75. Fidelity is most useful in comparing different alerts of the same type, of the same, uncommon application anomaly. Alert score is more useful in comparing alerts of different type. So to go back to the initial bit I was talking about focusing on the big rocks. So here we have, some alerts from the past week. We care about all new, and we might increase the alert score to some value. In some systems, what you will see is actually given some of the alerts a little earlier in the chain based on the judgment of the red team security experts, machine learning experts. Even though they do exist earlier in the chain, they are more significant. And this will change from version to version to a degree, version to version of Stellar Cyber. So, if we start here, I had however many of these, and if I up this to 70 or 80, this went way down, but some of these, and I suspect some of that has to do with testing on the system. These are the ones that, in the judgment of our PhD security experts, based on the way the numbers are calculated, are the ones you want to focus on. Did that make sense? There's a number of factors coming in here. It's a very good question. And I just want to make sure it makes sense because it also is critical to workflow in terms of deciding what we're going to focus on first. I'm going to leave that open in case there's another question about that. And we're going to move on. I'm going to start moving a little bit faster. There have been some excellent questions, and we've gotten a wee bit behind. So let's try and move through. So incident analyze workflow. What are we talking about here? So when we are looking at an incident, we have some interesting, this isn't a really pretty one, I know, but it's still illustrative. It displays the graph of the overall incident. And I don't know why GraphML realized or thought that these particular two external hosts and two internal hosts were related, but we have our observables. These are the entities. I wonder if I have anything sexier on my. All right, so this one, I have a user, I have a host, some processes, and these are my indices. The observables are what some vendors call artifacts. We happen to call them observables. Now, on the timeline, we're actually looking at the original alerts. So, and here we can actually, take a look at the specific alerts. We have the alert details, just like we would. And here we can actually, take a look at the specific alerts. We have the alert details, just like we would anywhere else, and lots of good things.